Okay, so good day, good evening, good day. So we will be discussing more on the second and third law of thermodynamics. Okay, so the second law of thermodynamics dictates the limits on the conversion of heat into work. So it also tells whether a particular process is feasible or not. So as a consequence, it also introduces the concept of entropy. While the third law of thermodynamics defines the absolute zero of entropy. Okay, so what's the difference between reversible and irreversible thermodynamic process? So as you can see in the diagram, so irreversible process are have a straight line, while reversible process has a curved line. So the process in which the system and the surroundings can be rebuilt from the final state to the original state is called a reversible process, while all the actions that take place in nature are irreversible process. Like for example, if you burn wood, then it will turn to ashes. So you cannot reverse it by turning ashes, turning it back to wood. Okay, so that's an irreversible process. Okay, next, explain the difference between enthalpy and entropy. So enthalpy is a measure of total heat content in a thermodynamic system under constant pressure, while entropy is the measurement of the level of disorder in a thermodynamic system. Okay, so for example, in an ice and then turning into water, so ice has low entropy because the molecules uh, are in order, and then when it turns to liquid, so the molecules move and entropy increases, while its enthalpy also, so since ice has a less heat than when it turns to liquid, so also the enthalpy increases since heat increases during the conversion from ice to water. Okay, but in some cases there are also cases like, for example, if you compress air, so if you compress air, then the entropy or the randomness of the molecules in the air decreases, so entropy decreases. But if you compress air, heat energy increases, so enthalpy increases. So in case for air, compressed air, so enthalpy and entropy are uh, inversely proportional. But in case of ice turning to water, so enthalpy and entropy are directly proportional. So it depends on how these two are being used in the molecule or the system. Okay. Next, so explain the principles and fundamentals of a heat engine. So a heat engine uses heat to generate power. So it draws heat from a reservoir, uses that heat to do work such as move a piston or lift weights, and then releases that heat energy into the sink. So this was already discussed on our previous topics. So what are the types of heat engines? So we have internal combustion engines, we have external combustion engines. So usually internal combustion engine like gasoline and diesel engines, so where fuel combustion generates high temperature gases to produce a mechanical work. And then while steam engines, so high temperature gas is produced, but mechanical work is done outside of the steam boiler, so externally. So it is also called as external combustion engine, while gas turbines are also called internal combustion engines since the combustion inside the gas turbines is used and work is directly made also in the gas turbine. So it is not really used externally, but rather internally. Okay, so it's also an internal combustion engine. So what is the working principle? So for this type, this is kind of diesel and gasoline engine. So for diesel engine, we have the working principle for diesel engine is there are four ways, or this is for what should we forgot the name. So it for process, I think. So first we have the intake, and then compression, and then power exhaust. So let's first discuss intake. So intake, when the piston goes down, the intake valve opens and the air enters into the cylinder. So the moving down of the piston also creates a suction or a vacuum that in which air will go inside the cylinder as the piston goes down. And then as the piston goes up, the intake valve closes while all the valves are closed, and then the air inside the cylinder is compressed by the piston. So compression takes place. After compression, when at max the pressure goes maximum, and then the intake and the exhaust valve are all closed, and then suddenly a fuel injector sprays fuel inside the compressed or inside the combustion chamber, where compressed air is at its highest pressure and also with high temperature. And then as the combustion occurs, piston goes down, pushing the piston down, creating a rotational motion into the crankshaft. And then as the piston goes up again, the exhaust valve opens, and then the exhaust or the smoke or the byproducts of the combustion goes out to from the exhaust valve and goes into the outside the engine. Okay, so that are the four processes of the internal combustion engine. So intake, compression, power, and exhaust. Okay, so there are two types of internal combustion and there are types of internal combustion engines. So we have first the spark ignition gasoline engines made using the Otto cycle. We have also the compression or compression ignition engines by Rudolf Diesel, or also called the diesel engines. And we have also rotary engines like the one rotating in our slide. So that is a rotary engine, and it is used usually for hydrogen powered cars. And then we have also gas turbines. So these are internal combustion engines, since the combustion is put into work internally inside the engine. So that's why they're called internal combustion engine. Okay, so now we will be differentiating the diesel cycle and the Otto cycle. Okay, so the diesel cycle, so as you can see from 1 to 2, so 1 to 2, this is the suction. So as you can remember, we have intake, compression, power, exhaust. So 1 to 2 is intake, or the suction of air inside the cylinder. So always always remember this working principle. So this is the one that we will be discussing on the diesel cycle. Okay, so first we have the Otto. We have the intake. 1 to 2 is the intake, in which air is drawn inside the cylinder. So pressure is not increasing, and since the piston is moving downward, then the volume is increasing. After that, 2 to 3, as the piston goes up, so and then intake valve closes, then the air is compressed, increasing its pressure while decreasing its volume, right? So that is the 2 to 3. This one, 2 to 3. This 2 to 3 slope. Okay, that one. And then after that, 3 to 4 is fuel is added, and then as fuel is added, combustion occurs, thereby expanding or pushing the piston downward. So as the piston goes downward, pressure is maintained at its highest. Okay, and the piston is pushed by the combustion, and that's 3 to 4. And then after that, 4 to 5, that is the time in which expansion takes place. 4 to 5, the piston moves more downward, and then due to the expansion of gases, so combustion is already done, but the expansion of gas is still ongoing. Okay, so that's 4 to 5. And then after that, 5 to 2. So 5 to 2. So this process, it is the start of start of exhaust stroke. So as the exhaust opens, and then the piston is at its lowest point, that is the time in which heat rejection is taking place. So heat rejection is taking place first because the heat was already used by the piston during its downward stroke, and then next is the exhaust valve is also open at this time. So heat is rejected or going out of the engine, and then after that it continues to the heat continues to be removed, and then also the exhaust gases are already also removed as the piston goes up from 2 to 1. Okay, so that is more on the diesel cycle. Next, now we will be going to the Otto cycle. So the Otto cycle from 0 to 1, so as you can see in the diagram, so it's starting from 0. Okay, so from 0 to 1, it is the time in which air is, as the piston goes down, volume increases, and then air is drawn inside the cylinder. So the pressure is maintained at its atmospheric pressure. And then after that, 0 to 1, then 1 to 2, it is the time in which the piston goes up, where the intake valve and the exhaust valve are closed, and then the air is compressed. Okay. So after the compression, since there is less volume of air, so there is also less pressure. So for Otto cycle, there is less volume of air than the diesel cycle. So we cannot. So the pressure in the Otto cycle is lower. The compression pressure of the Otto cycle is lower than the diesel cycle. Then after that, 2 to 3, it is the time in which the air and fuel mixture of the gasoline is ignited by the spark plug, and that's 2 to 3. So spark plug ignites the fuel and air mixture. So after that, 3 to 4. So this 2 to 3. So during the the activation of spark plug, combustion occurs, thereby increasing the pressure to its highest, increasing the pressure more. And then at that point in which the maximum pressure is reached, it is also the time in which the piston will be pushed by the expansion of gases. So 3 to 4, it is the downward stroke of the power stroke. Okay, and then the piston goes down, so that is the downward motion of the piston. And then at 4 to 1, that is that is the start of the opening of the exhaust valve. So heat rejection is taking place at constant volume, and then as the piston goes upward, then 1 to 0. So that is the time in which more of the exhaust are removed from the combustion chamber, and then it will start again back to intake stroke. So it is a cycle. Okay, so that is, so the difference in Otto cycle and diesel cycle. So heat in Otto cycle, heat addition in system at constant volume, while in diesel, heat addition in system at constant pressure. So the compression ratio of the Otto cycle is lower than the diesel cycle. That's also why the compression pressure is also low in Otto than in diesel cycle. So in Otto cycle, high efficiency at same compression ratio, while diesel cycle is low efficiency at same compression ratio. So you should increase the compression ratio so that the diesel cycle will have higher efficiency. So petrol engine works on Otto cycle, where diesel engine is working on diesel cycle. Spark plug is required in Otto, while fuel injector is required in diesel cycle. So in Otto cycle, more or less, air and fuel mixture is inserted from the inlet valve, while in diesel cycle, only air is inserted in the inlet from the inlet valve. So after generating spark, combustion takes place in Otto cycle, while in diesel cycle, combustion takes place due to hot air and fuel received from fuel injector. So in compression stroke, air fuel is compressed, while for diesel, in compression stroke, only air is compressed. So number 9, fuel is inserted during the suction stroke in Otto cycle, while diesel cycle, fuel is inserted at the end of compression stroke. So number 10, Otto cycle, there is no need of high pressure and temperature because spark plug or spark starts the combustion. While in diesel cycle, it needs high pressure and temperature so that combustion will start when fuel is injected. Okay, so for Otto cycle, lastly, low compression ratio, and diesel cycle has high compression ratio. Okay. Next, so we will be discussing about, or maybe we will stop this video and then we will continue discussing this number 7 topic on our part 2 of this video. So I hope you learned many things from our topic for today, and please do subscribe and share our video so that you can so that the information will also be shared, and then I hope to see you on our next video. So bye.